right? It's my like vegetable. And low sodium V8 juice. There was like a 3 month time I couldn't. They were gone. They just were gone. So we don't have staples. Oh no! Oh no! Did you jam it?
Well, it wasn't working before.
Wait, let's see. Who broke it? Did you break it and then pass it on?
I don't think so. It works for me.
You're making fun of Ashley.
Hey, at least I didn't
We'll be right back. We have a staple incident here. Okay, Doug. Good job. Come on, let's do it. All right. You guys anyone ever take karate? Okay. No, you did not follow directions. Oh my goodness, I'm getting stressed. Okay, so so our copiers don't have staples in them, and I know that sounds like not a big problem, but it is a supply problem. It's just flat out there's no staples to be gotten for our copiers anymore. So I hope this doesn't keep going. I don't care if we run out of paper. Do you know what I'm going to do? We're going to be teaching up on the board, man. Old school whiteboard teaching. Did you break it? Oh boy. I think what happens is once it gets pretty low, the spring isn't strong enough. Oh, there was something in there. Someone did jam it up. It was jammed up and passed on. Hit it. Okay, you guys are killing me on the stapler. We had no problem first hour. Just saying. Okay, so I'm going to get going. We're almost done stapling. All right, a couple things to mark. And then anyone watch this? I don't really care. I think it's fine if you didn't. But I put these things down. But I also wanted to give credit where I stole my drawings. I think read this article. I took all those pictures from that article and put them in my notes. Hey, it's on the internet. We can grab it and steal it. And then I think this is a video from somebody else about the parts, and it's real short and sweet. One thing maybe to mark: a chord is a segment, meaning it has two endpoints. Because you may think, what's different with this thing in green called a secant? Well, that's a line. A secant is a line that crosses a circle at 2 points, but it keeps going through the circle. A chord is confined inside that circle. Couple other things. I want you to make a real big point of this, and we're going to be a true geometry teacher would not be very happy with me that we're not doing proofs. It's because of this whole Math 2, Math 1, Math 3 thing, and the convoluted decision to our school to make that happen, and then you got geometry sometimes in Math 1, and then geometry in Math 2. So this would be a theorem is what I'm getting at. Now, first of all, let me talk about a diameter. Of course, a diameter is 2 watts. 3, 2, 1, go. Radii, for those that were listening, good. All right, 2 radii. So count this as a radius, from this center to this point. When it hits a tangent line at a point of tangency, then that is a theorem. Then that would have to be a 90-degree angle. We're going to have stuff where that comes up later, and we need to know that. So that is called a point of tangency, and that radius is hitting at that point of tangency. One other thing that I marked in the other one, this other drawing is not any different. I guess I kind of like the sequence of showing diameter, chord, secant line, tangent line. I like that in a row. But they also mark what an arc is. Don't worry about this line up here. That's just pickup from my, from my cutting through a print screen. But an arc has two things. An arc has a measure, and you might want to mark this up in this drawing right here. And I did this for speed, so we had something to look at, and then add a couple things. An arc measure is in degrees, and that's what we're going to do today. What's a full circle, by the way? 3, 2, 1, go. 360. So this arc measure from here all the way back to here is also 360. So you can mark the outer edge in terms of degrees. It's so you can figure out proportionally what you're dealing with in a circle is really the idea behind that. But then later, probably next week, we're going to talk about arc length. And actually, I should put this in here. Arc length is related, I'm not going to write it down, but it's related to circumference. And arc length is in terms of a definable measure like feet, stupid pen, every day. Inches, let's give the metric system some cred. Meters, dot, 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 dot. It's actually a linear distance. There's many things out in the world that's curved, but I can walk that curve. How many miles did I walk over that curve? I went running yesterday. I can't believe it. I can't believe my knees are kind of holding up. But I definitely have almost a circular path that circles my house. So that's like an arc length, what we do. It really is almost circular. It's got some little turns here and there. But okay, now, for purposes, you have a blank picture. Go ahead and mark this sucker up. And some people shook their heads that some of these things they had not seen. It's not hard, though. Really, this first page is just some definitions. I put my, sorry, walking around the room, those in the video there. I don't know, why did they get to walking them out? So I know this seems like a big swing, but we could have some circle questions now with some trig in it. All right. And then, so that's why we do trig first, then we go to these circle units, and then some of the other things later, like polygons and quadrilaterals. We can use trig to solve some of those parts too. So that's why you had to get that trig unit in. Now it can be used in these. But anyway, blabbering outside there. A, B, C, D, E, F, G, if you want to follow along with my notes. Very simple. The only thing I didn't define them. I just were last hour talked about them. Like a radius would be OG, OA, OB, OC, and they should have little segment marks above them. That ain't no thing. We should know what a radius is. I'm not going to mark every single thing because some have more than one, like 6, 7, 8 different possibilities. I only have one diameter. The one diameter that I have is GC marked. You can mark more. We could make more, but from this drawing, that's the only one I see. Now, a diameter is a chord. All right, so I could put it in the chord section. All right, but it's more specifically a diameter, so the best definition. I do have two chords that are not diameters. That is ED, and I can mark those both, and FD. And then again, these are with segments on them because they end. They have edges there, so on and so forth. Or they stop inside the circle. They're not lines. Okay, so now we have the first thing, which is called a central angle. First of all, watch this. You already know this. What's this measure when I go like this and I go blah, 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 and then end up right there? What's that measure? 3, 2, 1, go. I mean, you can almost think about this. Looks like, when we had the coordinate plane unit circle. That's kind of why. All right, sorry. That was not COVID related. That was just a tickle in the nose. All right, but anyway, we know that, and that's why kind of like with unit circle, we thought we should do circles last year right after unit circle, and I don't know if that really kind of fit, but we already know that. So one thing that we should know, well, let's just talk about what a central angle is first. I almost got into the measures, which is next page. A central angle is whose vertex is at the center. So GOA, for instance, and then remind yourself how to name an angle. AOB. I could do a whole bunch of these. I could even skip, let's say, angle AOC, which is looks like obtuse to me, right? And so on and so on and so forth. BOC, GOB, GOB, or BOG. Those would be another central angle where O is the vertex. And then we'll talk about next page what an angle measure is of those related to the arc length. Very simple concept. I don't have this defined, but hopefully you get this real quick. In inscribed angle, I should put that the vertex is on circle. Let's do cave person language. Vertex. Not on the center, on circle. And then we'll talk about that measure next page. I don't want to jump ahead of myself. So the inscribed angle is vertex is on the circle, which is this one, EDF or FDE. I'll stick with that, EDF. Okay, I only have one example of that as I'm looking at this. Well, I guess I could argue if I continued this AO and went through to this one, then angle A right here would be an inscribed angle because it's vertex. Angle B could be, but I'd have to extend these arcs. So I guess I do have a couple other ones. All right. And then the whole idea, before we go on to the next page and talk about measures, the idea of a minor arc, a major arc, and a semicircle. So put that at the bottom here, just examples of it. First of all, a minor arc is less than, not just 90, 180. So we got a whole bunch of them. And I go ahead and mark them with highlighting, but I only take a couple. I mean, I don't know, GA, but here's the symbolism. It's an arc. Because you got to be careful. I mean, look at when I do AB. What are you talking about? Are you talking about? I guess I had another chord. I didn't put that. I guess I should put that in the chords there. And I do want to do that now because I just came up with a different idea there. There's chord AB and there's arc AB. Those are two different things. So near your notes, I'm going to highlight that one and really make the difference. That is that arc, not the chord itself, but the arc outside there. And that would have measure. I don't know, it looks like it could be around 60 degrees if you know that this is 180. And we should know that. That's going to be the next page. That's a semicircle. This looks like about 1/3 of that. So I bet you arc AB is very close to 60 degrees if we measured it. All right, so I only want to hit that one. I could keep going on this. There's a million of these. Not a million, but there's a handful. I could even say arc AC. That's just a little bit bigger from A to C. Minor arcs only need 2 letters because they're in between 0 and 180. We can get the direct distance or angular distance, if you want to call it, from one point to the other. Major arcs are a problem, and these are going to be marked up with my highlighter for those that highlight a couple of these. And there's a whole bunch of them in here. We have a whole bunch of choices of major arcs. This is the first one I'm going to do, and I'll go ahead and mark it in blue. G, then which way am I going? I could go left or right. That is why I need another letter in the middle to tell me which direction I decided to go to end up here at D. If I just say GD, that is the shortest distance between G and D, which is a minor arc. If DC was 10 degrees, then arc GD would be 170 degrees. You get it? 2 letters, direct distance, direct angular shot. So for a major arc, I need that third letter to tell me I went this direction, and it could be any of the 3. It could be A, B, or C. It doesn't matter. So arc GAD is the exact same as arc GBD or GCD. Because all the A, B, or C told me to do is to go right, I guess, if we want to do our right-left thing. And if this was 10 degrees, this little sliver right here, then this arc is 190 degrees, which is greater than 180. And then I think with the other class, I think I did this. Well, what if I went this way and then I stopped at like B? All right, well, then it'd have to be G, starting at G, and then pick either F, E, D, or C. Let's just say like D, just to be crazy. But then I ended at B. It doesn't matter any of the letters you pick in the middle as long as you're going left. So GF, GE, or GD, or GC, then B. All right? And hopefully I did that right. And that'd be much greater than 180. Quick question.
Do you put the angle symbol in front of major arcs?
Oh yeah, no, I don't. I went off the rails there for a second. Nice. Ooh, that worked out. I can't believe. Oh my gosh, this may be a great day today. Did you see that? I was able to erase without erasing the highlighting. That just made my day. Oh, after you guys yesterday, and I kind of got crabby with you guys last. I'm sorry. Maybe I deserved it. I got a little worked up over those that are not doing what they're supposed to in here. Don't do that, Mr. S. Right? And then just all the rails went off yesterday. Like I had two phone incidents with a kid was literally sitting on his phone, like just talking out loud in a quiet class. Oh yeah, I'll be there at 4. I'm like, what are you doing? Just taking phone calls. And then another kid ordered Chick-fil-A and then comes in my class with a drink carrier and his Chick-fil-A bag right into my cat class. Unbelievable. I want to take that food and throw it out the window. All right, don't do that, Mr. S. Forget about it. Move on. Okay, all right, semicircles. Semicircles. All right, here we go. Half of an arc or half of a full circle, which is 180 degrees. You can put that there. You need 3 letters again. Which half are you talking about? All right, so arc, G, A, C. The reason I just brought that up is just because I erased efficiently there, I feel like this is going to be a better day. All right, so G to A to C. Remember, GC is a diameter. All right, so G to A to C is the right half of the semicircle. The left half is, again, you have options. G, it could be F, E, or D. G, let's say E, and then end at C. That's the left half. And then it's that arc thing that I kind of write in sloppily there. All right, so this is just a vocab section. I got the guy in the back stretching out his neck again. All right, here we go. Okay, do it again. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Anyone ever see the Elmo series of videos in Elmo Alphabet? I'd be amazed if anyone's seen Elmo. Come on, let's admit it. I've seen that show like 1,000 times. Yes. All right, Elmo Alphabet. Got an all-star cast in it. It's a very you guys should watch that. It's a good movie. Anyone ever see Elmo and Grouchland? Now that's a really good movie. Yes, Elmo and Grouchland's a very good movie. Where he gets his blanket stolen, and then he's got to go find it in Grouchland. You know it?
Yeah.
Yes. Okay, so now we got some measures, and we can talk about those measures, and it's actually listed over there what you should know about a central angle. And I really don't know. I don't want to formally define this and write this in words as a theorem. We're more about the brass tacks and algebra behind the geometry here. And then what did I say a full circle is? What's a full circle? 3, 2, 1, go. What is this arc measure all the way across or from there to there? What's the answer? 360. So there's obviously an equality relationship here. And the equality relationship is if an arc is 62 degrees, then its corresponding central angle has to be 62 degrees. So central angles equal the arc measure that they cut. And then vice versa. When a central angle cuts an arc, that arc is equal to that central angle. And these are things that you can mark up on a circle right off the bat when you have questions that have a whole bunch of things going on. Oh, no, sadistic other two Math 2 honors teachers, they got some monster questions that I really like. Multi-marked circles within circles and arcs and chords. And then you got to mark all these arcs and then get all these other angles. It's crazy stuff. By the way, what's half a circle? How many degrees? 180. I didn't do the 3, 2, 1. So we could surmise that this is 63 degrees because that is a chord. I'm sorry, that is a diameter, which does cut this into 180 on this side. So 63 is left over to fill this out. So guess what? 63 is left for this, which is what I have here. I did not put that, but now we can put that. Since that is hey, the heat's back on. That's 63 right there. All right, now I don't have this. Do you remember Desmos? Don't have a fit. But do you guys remember ever dealing with Desmos? Do you remember that? No, it's like the calculator thing, but then you can do a lot of good stuff with it. That was the one thing that I did do on Friday. I went to a Desmos thing. And he had a good Desmos that kind of showed this. He had a whole bunch of things. I had something I have to share with my CAT students with trig graphs. but it actually shows this. Think about if I tacked A and B, and then I pulled this vertex all the way to the vertex being on the circle itself. What's this blue angle? Do you think it's smaller or bigger than this 62-degree angle when I move that vertex? 3, 2, 1, go. Smaller. Doesn't that make sense? I mean, if I keep pulling this out there, that thing gets a super tiny little, sliver of an opening. I can almost pull it as far where that opening is almost like very, very small. So, hey, let's think about this. Think about this distance from here to here, and then this distance from here to here. What are those distances to each other? Equal or not equal? 3, 2, 1, go. I kind of want a radius, right? So isn't this twice as far as this vertex when I draw it this way? So what do you think fractionally that angle measure is then? What fraction of 62 degrees is it? Half. And that's what I have down there. That's why you should guess that. What I just showed you is the difference between an inscribed angle and a central angle. An inscribed angle cannot be equal to the arc it cuts. It's actually half of the arc that it cuts. So I think in the other hour I put 38 degrees, and then I couldn't mentally think what's half of 38. Some people switch these. I don't know how that happens. That's the robots and formulaic without thinking. Remember, if this was here, then this angle would be 38. This has to be smaller than that then. So that is 19, is that right? All right, so the measure of angle EDF, if it's 38 degrees, then let's say measure, wrong. I knew I did that. I caught myself. So if EF, that's what I marked, was equal to 38 degrees, then EDF, angle EDF, is equal to 19 degrees. Half of that, not equal. Okay, so the whole idea of an inscribed angle. All right, so those that can't pay attention and have a hard time sticking with me this whole time, we're not going to do well because I'm going to keep rolling. All right, so I think everything okay so far should be okay. This should be kind of common sense. 360 is a full circle. If these arcs are 360, then central angles equal. The only really new thing is maybe this inscribed angle. By the way, this can be tough. Inscribed angles can look different ways. They don't necessarily have to look like this. They can, and I'll show you when they come up. That's why we need a couple days on this. All right, now here's our next section. Imagine I pulled this rubber band of an angle and I pulled it outside of the circle. Or that's not the first one, our chord angle. Okay, fine. You're going to write this down and write the formula down. I want you to think about it, though. And then this is those who actually listen, who actually kind of have some sense out of what I say, actually remember things better. Now imagine this. Imagine, first of all, let's talk about why is it a chord angle. This is a chord. This is a chord. Let's say one more thing. What do we know about these two angle measures across from each other? First of all, it starts with a V, what they are. What's the word that I'm looking for? 3, 2, 1, go. Vertical. I swear to gosh, I know there's some of you in this room that has never answered one of my questions all year long since August. All right? That's how I feel about you, by the way. But imagine if I put this center or this vertex on the center itself. Don't you agree? Don't you agree that this arc and this arc would be equal then? Because they're both vertical, they're both equal, and central angles are equal to the arcs that they cut, correct? Yes? Now imagine as I pull this to the right. As I pull this to the right and these angles don't change, then this arc gets smaller, but this arc gets bigger at the same time, correct? They change proportionally, all right? So then what ends up happening is this angle is no longer equal to the arc it cuts. It's equal to the average of these two arcs that it cuts and its vertical brother or sister cuts. Because when I move this gets smaller, this gets bigger proportionally. So if it's on the center itself, it's equal to this arc. When it moves off the center, it's equal to the average of these two arcs. And that's what that formula actually says there. Who cares? Memorize if you didn't like anything that I said there. But if you did like it, that's why you're getting an A in my class. If you can't listen to those things, then that's why we're doing what we're doing. So I try to do that every single time. Not just throw a formula at your face. Now, it's a little out of order. Imagine I had a vertical angle. Wrong. Imagine I had a central angle equal to this arc I cut. Imagine I pull this to here, half of that arc that it cuts. Now imagine I yank that out to the outside of the circle. This keeps getting smaller and smaller and smaller as I pull further and further and further. By the way, why is this called a secant-secant angle? This is a secant, and this is a secant line. All right, they go forever, but they're emulating from the same point. Call that angle X right there, point X. Okay, now you have to incorporate, that happened to me last hour, that little pen thing. That's funny. Same exact position. This actually cuts two arcs on the interior of that angle. No longer just CD. Now it cuts this little AB out here. All right? So the formula for this, it's not only half of CD. Listen, it's smaller than that because you pulled that point outside of the circle. If it was right here, it'd be equal to half of CD. Now it's equal to half of CD minus AB, and that's how that angle gets smaller. Who cares? Memorize it. But it is true, that's what's behind it. If you compare this to this, and it's just a inscribed angle, angle X is smaller than this angle that I put right here. This angle is half of just CD. This angle is half of the subtraction of these two arcs, which makes it smaller. So this is a way to rationalize out a formula. And I think for some people it does work out when I do these things. And that's what I have to care about, right? For those that do that. All right, the next one. Well, all this is a tangent, because it hits this circle once, secant. Still, this angle X cuts this arc. And those that have highlighters, you should do this. And this arc. And that arc is still a minor arc, that AC. Right? That does not look like it's greater than 180 degrees. So I can use two letters for that. It's the same formula. Fumble. Memorize. Right? And then the last one. This is a tangent. By the way, what's a full circle? 3, 2, 1, go. So actually, the blue arc and the yellow arc do add up to 360. There's no doubt about it. Okay? So those add up to 360. This is a tangent angle measure. So we're talking about angle X on the outside again. It is exactly the same. Big arc minus small arc. All right? You need to get more sleep there, neck stretcher. Okay, so look at the difference between these last two sections. And then we could, this is all the new information. But you really shouldn't feel overloaded. You should know what radii, chords, diameters. That was page 1. Okay, I introduced the new world of arcs, maybe. Arcs add up to 360. Right? And then an inscribed angle. That's half of the arc it cuts. And then these two formulas, really. They're really just two. When it's a chord, when the angle's in the inside, add. Angle on the outside, subtract. And they're almost the same formula if that's the case. Okay, so proceeding on, and we're done at 08, which gives me only 5 minutes. Give you an option, because actually you have everything in your toolbox to do your homework, but I'm going to keep blabbering, for those that might look at it. I might finish this tomorrow and have something else to do in addition to that homework. So that is not necessarily tomorrow. I know we're a little short on time, but I'm going to hit a couple of these. These are for people that can we read and mark. Can we mark things appropriately? So here we go. In this circle, measure of ER. So measure means degrees. When it's actual arc length, that's a different marking. That's here, that's 38. So what am I dealing with here? So that's 38 degrees, and I mark it. And then OT, that is this big one. All right, so we got directly what I need here. This is 121. What is OUT? All right, and that is measure of angle OUT is that last formula I just told you. This is called a secant. And then you type it on your calculator and press enter. All right? Always funny, people ask me, should I be in degrees or radians in my calculator? Does this have anything to do with trig, yes or no? No. It's an invalid question. You only have to tell your calculator when you touch in trig if you're in degrees or radians. All right. This is a weird question because they have a distractor here that's not needed. But diameter is needed. You can't assume straight lines in math, but it is funny that they mentioned that it's a diameter. I don't think they really have to. And then x to t, the direct measure from x to t is 132. Now I find this curious because this is useless. Draw a chord that connects points x and t. Great. Has nothing to do with solving this question. Because then the next thing they ask is, what is the measure of x, u, t, which I could go through that. Really all I needed was this arc measure, because that is a secant tangent angle measure. 1/2 big minus small. How do I find that other angle measure? What do these all add up to become? 180. I feel like that minute didn't even move. Didn't I say it was 103 about 7 minutes ago? All right, so this would be 48, I think. Can anyone shake their head and agree with my mental math? Thank you. So then this one is, again, I'm not even going to name it. I'm just going to do 1/2, 132, pen, stupid computer. Okay, 132 minus 48, 1/2 of that. They got more of the same of this one. I think this is where I finished. I did finish with the other group, and then I just kind of scanned on the other page here. But I kind of like this one because it does show something. And I want to add something to this or give you at least some, if you go to it, like say you moved, like, oh, poor Huzaifa moved, right? And he went to like a geometry class, and he had a geometry stickler. OH and ES, those are segments. So those are actually chords. If I give the name OH and ES, then make it a congruent symbol. But I really want you to know those are segments. So I want you to know that by converting that to a congruent symbol with the names OH and ES. It's a really semantic detail that some math sticklers would hit you with. And notice what they have here. That's the segment. That's the segment. And they say those two segments are equal, but they only give you one of the arc measures as 41 degrees, and they don't say anything in the statements, but all of a sudden the other one's marked as 41 degrees. Do you notice that? So it's in your statement, but the drawing has another marking. And I want to mark this down as a theorem that you should know. When the chords are equal in a circle, then the arcs that they cut or intercept are equal to each other. So this kind of shows that, and that's what I could kind of end on this as far as solving this is concerned. The problem with this, though, finding EUH is it cuts everything but those 241 degrees. So the big arc is from here to here. The small arc here is only from here to here, and then stop. So it's everything but the 41s. By the way, what's a full circle? 3, 2, 1, go. So how do I get that blue arc? I have to take 360 minus 41 minus 41 minus 171. Last hour refused to do it for me. They're on strike. So 253, right? Is that what 171 plus 82 is? 253. So what does that leave? 107? Okay, so 107. Josh is like my mental calculator, right? You're like the mental math guy, correct? All right, so 107. All right, so this measure is half, yet again, 171 minus 107. That's what this angle measure is. So this is the kind of thing you get with these questions, a whole bunch of different ones. When you go to page 4, it's exactly what your homework looks like. And I think I had more time to work with it. Got a bunch of the same. 13's a tangent, tangents. 14's a chord, chord. It's half sum of those two arcs. I do want to talk about 16 tomorrow, fumble. Do you know what 16 is? This is actually the vertex is on the center itself. I know that's a tangent line, but that's actually an inscribed angle measure. So you know what the measure is? It's not 230, it's another oxygen stealer in this row 4. 1/5. Isn't half of 230 115? I don't care, Mrs. Samuels. Your hour is over. I'm out of here. Isn't half of 230 115 from what I checked the last time? 100 plus 100 is 200. 15 plus 15 is 30. Bye, everybody. Bye, Mr. Samuels. Not one student said goodbye to me as they left. This is teaching in America. Nobody